having better success than me. My network keeps dropping off.
Well, if you use up-to-date software,
Then nothing would work.
Ben, can we get some crowd control here, please? Keep the ruckus down.
Well, I mean, right now we have a problem that we don't have a driver, scribe, or note taker.
Okay, I'll take notes. It's, bigger problem is I don't think I have a VGA download, but I have HDMI only because I was planning to see it on this one. Do you have a VGA?
I have a VGA. See if my graphics drivers actually work.
I actually bought a VGA dongle, but it doesn't work. It doesn't work with this.
That's fine. That's kind of crappy. That's better. Actually, Jean-Marc, are you on Jabber?
I'm sorry?
Are you on Jabber?
No. Can you beat scribe and note taker? We only have chairs and presenters and ADs. You're the only one.
Well, we can get Jameson to take notes. So note taking is pretty easy. All you have to do is record conclusions. Like that doesn't have to be minute by minute, blow by blow. There is, if you go
Give you a
to
link to Etherpad.
yeah, if you go to the agenda, there's an Etherpad link.
If you just go to IETF, just Google IETF98 and then agenda, and you'll get an HTML agenda, and then look for codec. This is the, I think, first meeting where we can actually go personally meet everyone in the room.
So somewhere over in one of these links on the side is an Etherpad.
The big X, I think, will take us to all the materials. And,
I was going
Either that one or that one.
the big X.
present sort of a quick update on what happened so history.
Well, I think there's a no, not that.
Exactly where we should be going.
Close.
But we've already had dinner with these folks.
Yeah, I don't think we're getting more.
Etherpad for nothing. There you go. Yeah, so you should be able to just jot things directly in there.
All right. A bigger responsibility.
Mo, are you going to be backup note taker?
Yeah, I'll be popping that.
Is what?
I mean, I was planning an agenda bashing, but I think there's a good.
Yeah, okay.
And he asked, like, is that something we can send to the mail? Yeah, probably.
Dot patch, I don't think is a viable format to submit slides in. You uploaded dot patch proceedings.
Yes, we did.
Oh, that's funny, the stuff I was talking about is unrelated to that.
Okay.
Well, dot patch and hard GZ, headers list audio.
All right, so I guess we'll go ahead and get started. I'm not even sure there's any remote participants. So yeah, so this is the first meeting of the codec working group in a while. I think the last meeting we had was IETF 82 in 2011. So I'm Tim Terry, that's Mo Zanati, we're your chairs. Everyone should know the note well. If you have IPR on contributions that you make, you must disclose it. That's the fine print. This is our current agenda, which is just us talking for a few minutes and then you guys giving your presentation. Presume there are any last minute additions to the agenda? All right. So just a quick review of our milestones. We have two. One is the draft that you're talking about today, which was supposed to be done in November. So I guess we'll have to update that date. And the other one was the bug fix draft, which has passed working group last call and was waiting on us to figure out how to do get a permanent URL for the new test vectors, which I think has now been sorted. And so now it's just waiting on me to do the write-up and hand it off to Ben. So that should hopefully happen pretty soon. All right, that'll turn it over to you guys. Yep, give me a second. I mean, so at least we can review the draft among us, but yeah, it feels like there should probably be more people here to do a proper review of this, because I think we've already looked at this to at least some extent. So I don't know if you want to keep going or what your plan is.
Yeah, I'd like to present. I see Mark Harris on.
Oh, yeah. Okay, so we have at least one person who's. Yeah. So yeah. Yeah. Go ahead.
So hi everyone. I'm here to present ambisonics in an Opus container. This was specified in our draft on the codec for ambisonics. I'm Andrew Allen, and so let's begin. Okay, so the agenda is fairly straightforward. We're going to start with a foundation on ambisonics, what that format is, and how it relates to spatial audio and 3D audio. And then we'll discuss what our spec proposition is involving adding ambisonics to Opus, including the new proposed mappings, as well as what kinds of calculations would be involved in those mappings. So let's start first with ambisonic foundations. Just fundamentally, what is spatial audio? Spatial audio is the idea that you have a sort of psychoacoustic sense of when an object like this loudspeaker is existing in some space away from you in some position, the arrival path of the signal from that speaker to your left ear and to your right ear differs, and it differs because of the difference in distance as well as the diffraction around your head and from your shoulder width and pinna and all those kinds of things, and all of that processing that happens physically around your ears causes us different filtering in each ear, and this different filtering our brain interprets as a localization cue. And so then what we do is we sync up those two left and right signals together. We hear it as a composite signal and we interpret it as, oh, it's over here or over there. This is how basically HRTFs, head related transfer functions, work, where you have a filter that describes that distance, that path distance for each ear for a given position. And what ambisonics allows us to do is it allows us to not just model one point at a time, but it allows us to model the entire sound field around the head. So this has a lot of advantages in video games, in VR audio, in 360 video, anything where you're going to have sounds existing from all sides around you. Ambisonics is a very nice compact formulation for that representation. So what do I mean by all around your head? Well, if we pretend that this blue sphere is a not an omnidirectional microphone, but a spherical microphone. That it can capture. It's some sort of spherical capsule, and it can capture sound across the whole position of it. And if I were to place impulses right there and there, and let them charge out and have them capture onto the sphere, you would see that they would capture at 2 different points in the microphone. This is like at a particular time snapshot, right? And this is telling you maybe the energy at that particular snapshot. Then what we have is we have some representation of 2 signals arriving at 2 different locations on the sphere. So this might be this is what reality would be, and we can use truncated spherical harmonics, otherwise known as ambisonics, as a way to represent a n-order approximation to this function. So if we consider first-order ambisonics first, first-order ambisonics, all ambisonics in general consists of what are called spherical harmonics. Spherical harmonics are a set of orthogonal bases functions that describe shapes on a sphere or positions on a sphere, however you want to think about it. And you can truncate the series, and this basically controls the resolution at which you can describe the spatial acuity of the shape contour of the pattern you're trying to describe. If we use just first order, we get 4 components. We get the one at the top is an omnidirectional channel, and then we get these 3 directional modes, one along the X, one along the Y, one along the Z axis. And with just these 3 channels, we can then express directional signals that arrive from all directions. And so if we wanted to use just these 4 channels, we can get a first order approximation of that, which looks like this. Now that doesn't look particularly great, but it has the right directivity, more or less. It's given the function that it has, it can at least point in somewhat the right direction. And if we want it, the way that this is built is we have those 4 components, and we just have some weighted contribution of those 4, which best approximates the signal that we were actually going for. This is all fine and dandy for very wide diffuse fields, where you have, for example, like you're recording this, like you're out near the ocean and you're just recording a soundscape around the ocean, something where the directivity doesn't matter as much. But in our example here, we had something that had very, very sharp directivity to it with 2 very distinct sources. So for that, we would need to extend up to include more channels, otherwise known as higher order ambisonics. So with higher order ambisonics, what you see here, this is third order ambisonics, we introduce additional basis functions. And these are more spherical harmonic shapes that can contribute to effectively a higher spatial resolution that we can use to describe the scene. And a third order approximation gives us a much better fit to reality. And obviously, as you go up, you can get a finer and finer approximation. Currently, there's a lot of systems that use third order, but we pretty much refer to higher order ambisonics as just anything above first order. Third order is a goal right now, but as you can see, the number of channels rises quadratically with the order. So given more bandwidth and given better compression schemes and things, we might be able to just really more bandwidth, we might be able to expand higher orders. But the point is that with ambisonics, there is a defined number of channels for a given order, but the order can vary depending on the content. And you get closer and closer to what you actually had in reality. Okay. So how these systems are typically rendered is usually through either a loudspeaker array like what you see here, or through a virtual loudspeaker array, which would be the same kind of representation, but replacing the physical loudspeakers with some sort of set of HRTF filters corresponding for each loudspeaker. What you do then is you take the ambisonic signal that has that representation of spherical harmonic modes, and you project it into what's called a loudspeaker space. And the projection involves, typically it involves like a pseudo inverse of what's called the encoding matrix. So you get a decoding matrix that projects your ambisonic signal into some defined loudspeaker array like this. And if you did this binaurally over the headphones, you would have a corresponding HRTF for each one of these for both the left and right ear. So in this case, I think this is 32 speakers. So for 32 speakers, you would have 64 HRTFs that you would process, 32 for each ear, sum them all up, and then you would get the third order ambisonic or whatever n order ambisonic sound field rendered to the ears. Additionally, you could also envision, so this gives you a sense of a sound field that's around your head, and just like if you were within a loudspeaker array, you can actually tilt your head from side to side, you can turn left or right, up or down. The loudspeakers would stay exactly where they are, and hence you're actually able to rotate the sound field respectively to where your head orientation is. So this allows us to give that sense that there's an actual 3D space to this. So this is not head tracked. This is head tracked. In addition to that, a lot of designers that work in this space also want to have, dialogue or soundtracks or things like that, things that they don't want head tracked, but they still think are integral to creating the scene. And so we represent that with this pair of headphones that are also on your head. So if you extend the visual metaphor, the ambisonic sound field gets projected to these loudspeakers, and your head moves, the loudspeakers stay put, and the headphones represents a set of non-diegetic audio, non-head tracked audio that would follow your ears no matter which orientation you have. So that's a basic overview of ambisonics without going too deep into the math. And now we want to discuss how to add ambisonics into Opus, starting first with the mappings and then into the calculations. So we have two proposed channel mappings for ambisonics, channel mappings 2 and 3. And the specification for both of these is that the demixer implementation must interpret these Opus streams for channel mapping 2 or 3 as containing ambisonics. And we'll explain what that means in just a second, but we'll explain that in a second. Okay, right. So for channel mappings 2 and 3, there's a expected number of channels depending on the order and n. N can be 0 through 14, and this additional parameter j, which can either be 0 or 1. N will describe the ambisonic order, and like I said before, the number of channels goes up quadratically in respect to order. So you see this in the 1 plus n squared, and the 2j is the addition of that headphone track that I was visually explaining just a moment before. So it can you can have either or for that combination, and both channel mappings would expect always the number of channels you have to be of this form. Additionally, if you're going to use mixed order ambisonics, mixed order would be you may want to use the third order horizontal, but only the first order vertical, for example, and you would not include some of the basis functions for that mixed order. You would just simply want to zero out those channels that you don't use and still send the full order of ambisonic channels. The order of these ambisonics is ordered by what is called the ambisonics channel number, the ACN. This is a defined standard from the people that produced Ambex, and so we follow that as well. So it follows a very straightforward scheme. And we simply addendum ACN by including the additional left and right channel for the optional non-diegetic stereo at the end of the ACN channel numbers. Lastly, ambisonic channels, just like all Ambex ambisonics, they're expected to be normalized with SN3D, Schmidt semi-normalization. Now into the details of the calculations. In terms of the coding details for the differences between channel mapping 2 and 3. Channel mapping 2 is a direct per ambisonic channel coding scheme. The way this works is we code each ambisonic channel directly, and we have a variable bitrate allocation for each of those channels. More bits are placed in the omnidirectional channel, and less bits are placed in the directional channels. For channel mapping 3, this is a little bit fancier, and the proposal here is that we, because the sound field often has a lot of coherence, it's very often that a sound source will be, it's very often that the most compact representation of your sound field may in fact be better represented with a transformed space outside of from spherical harmonics, either to, for example, what I said before, a loudspeaker projection or some other arbitrary projection. We offer the ability of introducing a transform to the encoder and a known as the mixing matrix, and another transform known as the demixing matrix from the coded streams back to the output streams. In this example, the U vector is our input streams, which go up to C, which is the number of ACN channels with or without that additional stereo count. The encoder is some mixing matrix A, which can be a linear matrix like this, or it could be something else, depending on implementation details. The number of streams you end up coding is K, which will be the number of streams plus the number of coupled streams. The way we do the coupling is we couple, starting from the top, we just couple the, we assume you're transforming the space into some sort of coherent representation so that you can take advantage of coupling of each pair of X. And the demixing matrix that reprojects X back into your output streams is called the demixing matrix, and this is the matrix that we propose to store in the header, so that the encoder, as the encoder handles the mixing process, it will also store this demixing matrix so that the decoder can interpret that during the demixing scheme. So for the channel mapping tables, mapping 2's table looks very, very similar to mapping table 1. So if you're familiar with mapping family 1's mapping table, it will be very much the same, except it will have the requirements of channel count that we had said earlier. Channel mapping 3 mapping table will be replaced with this demixing matrix, and it will take up the it'll be fitted in the same position as the mapping table was before, and will extend to the count that it needs to. Okay, and I think that's it. So if there's any questions, please let me know, and thank you very much.
All right. Are there any questions, Mark? Oh, we have two. You have two remotes. It's hard to see the list from the side of the room.
I've never used Neat Echo. You can ask to speak to the mic, and then we'll enable your audio to the room. Or you can just lurk. So I had a question, Drew. So the channel mappings seem pretty straightforward. When you get into these higher order ambisonics and lots of channels, is there any consideration of work to actually make the encoding more efficient? Is there room to do that besides just channel mapping?
Yeah, so
Actual encoding?
Yeah, in terms of the encoding efficiency, a lot of that can be taken in by designing that A matrix. So especially with very, very high order ambisonics, unless you're dealing with very sharp directional signals, you're going to have a lot of coherence in the signal, and there's very likely that you can think of a matrix transform that would put your channel count into a much more compact representation. So for example, like let's say you have like 5th order ambisonics, which would be 64 channels, but you only have a handful of sources, 2 or 3 sources in the room at a given time, maybe a violin over here, someone talking over here, and a whale behind you. And so you might actually have a matrix that can actually go from 64 to 3, and then you end up only needing to encode 3 channels. Mm-hmm. And then demixing would be the re-expression of that back into the 64. So you might end up only needing to encode just a handful of channels, depending on how well you can design that A matrix.
Okay, so you're saying you basically do like track-based, individual source track-based encodings, and then specify a mixing matrix that generates how many ever channels you want for the higher order ambisonics, and then demix back down to the sources.
Right. That's definitely a strategy you could use if you are in control of knowing what the content was. There's other things you can do too, right? But any kind of way of basically using that A matrix as a way to compact the system is will give you a lot of benefit.
Okay.
So I think we had discussed on the list briefly that we drafted the original Aug Opus draft poorly, in the sense that it says that anything that was not listed in there, any channel mapping family not listed in the original draft should be treated as channel mapping 255 if you don't recognize what it is. And we had, I think, discussed some updates to that draft that would essentially go back and fix that language to say something more sensible. But I didn't see any of those in your latest ambisonics draft. Are you still planning to make those changes, or was that not clear? Or do we need...
I don't. Yeah, I believe perhaps that was not clear. I'd have to go back to talk with Jan about. I think if I understand you correctly, like the concern is that if for example, the decoder sees channel mapping 2 or 3 and doesn't know what to do with it, it reverts back to 255. Is that the concern?
Right? Well, so I think the basic problem is 255 has 255 basically says to use the same kind of channel mapping table that channel mapping family 1 has, and then just pretend like, just write out each individual channel as you decode it, and don't try to say like what that channel means or anything, which I think works basically fine for channel mapping family 2, but is more problematic for channel mapping family 3.
And this was why, so if you'd seen the previous draft doc that we had sent out, the initial one that we proposed had both the mapping table that you saw in mapping family 1 and this mixing matrix. And there was some discussion, I believe Mark Harris and a few other people mentioned, oh, you could actually optimize that out by just including effectively that mapping table as part of the demixing matrix. So we removed the mapping table from the most recent doc.
Right, which I still think was the correct thing to do, but I think you had a problem whether you removed that or not. And so the problem you had is that the table that you included was the output of, operated on the output of your mixing matrix and mapped to the final set of ambisonics channels. But the output of your mixing matrix could have been some different number than the number of channels you had in actual streams you encoded, which if you're interpreting the thing as 255, all you know is I have this many streams and have this many channels. It's like, now how do I map that to my C output channels?
So I guess the best proposal I could give at that point then would be to have the mapping table actually relate to what was actually encoded, so that at the worst case scenario is you just get back the streams you actually just coded, and use that as the mapping table. Right.
So we could do that, or we could just fix RFC 7845 to say what I meant to say when I originally drafted it, which is that the actual contents of the channel mapping table depend on what your channel mapping family is, and if you see one you don't know, you really can't do much with it. I think Mark Harris had identified 3 specific places in the RFC 7845 that we could update, and then we just have this draft make those updates. So I don't know if Mark, did you ever send text to the list on exactly what those changes should be? Yeah, our Jabber scribe.
So he said, I did not. So the question, the internet draft had a mapping table, but it was not compatible with that of mapping family 255.
Right, that's what I was saying.
Okay.
Thanks, Mark.
Yeah, so Mark, would you be willing to send the text that we would need to update 7845 to the list? All right. Let the notes show that Mark says okay.
We have two decades. Mark or Michael?
Yeah, so I think that was the only issue I had.
Jean-Marc Vananen-Mazoa. Just a minor comment. Also, I pointed out for the matrix, you need to put it in either little endian or big endian, but specify that. But also one thing I don't recall seeing is you would need to also make it clear what, whether you're column first or row first.
I think we say it's column-wise. I think we said that in the doc.
Sorry about that.
No worries. But we will specify the Indianness too. Yeah, I don't think that's in there yet. Mm-hmm.
Yeah, the draft does say column-wise.
Jabber Relay again. I think this is Mark again that says, I think that also the formula in figure 2 in the draft looks incorrect.
Formula in figure 2 in the draft.
That's the one that specifies order and degree based on K and N.
He is typing.
Actually, maybe I can put these on the overhead for everyone.
Yes, for example, if K equals 1, then degree equals -1.
Yeah. K. Yeah, that's. I think this should be. K. Well, if K. I see. Yeah, the correct formula. It's on the. It's from. It should be just straight from the AMBEX specification. So we'll make sure that that's cleaned up. So sorry about that.
Yeah, one of those might be 0 based and the other one 1 based.
It is 1 based. I think that's what it is. I think it's some shift of 1. Oh, actually, no, I think it's correct. So if we start from 0, K0 would, yeah, actually, I think it's correct. K1 would be -1 degree because K1 would be the second channel, which would be the first order degree -1. But I'll double check. I'll make sure that it's working correct and get back to you later today on that.
All right.
Jean-Marc Vananen-Mazoa. Can you explain a bit better how the presence or absence of the non-diegetic audio is signaled? I'm not sure I understand.
Yeah. So the way it's signaled is by the channel count. So we expect to see either an n+1² number of channels or an n+1² + 2 number of channels. So there's never any ambiguity there. So we can distinguish it just simply from that.
And so in mapping family 2, would the non-diegetic be included in the mapping table or not?
Yes. Yes.
And if so, as what, with what number? It would just be concatenated after it's the +2?
It expects, yeah, it will expect the stereo to be at the end on the input as well as the output. How we actually encode it, we'll probably likely send it to the coupled stream. So the mapping table will probably account for that and move the last 2 channels and so that they can be coded for the coupled stream and then move them back obviously.
Okay, so basically you would be, in fact, indirectly allowing to code the non-diegetic as 2 mono.
No, I think that the plan is that we will, or the way that I haven't upstreamed this code yet, but the way it works right now is if it does not detect non-diegetic stereo, and we just have some n+1² number of channels, we just code a set of mono streams. But if we have that,
I'm talking about the decoder side, like the format, it seems right now would allow you, if you decided to put 2 mono channels as non-diegetic, right?
Yes, you could. Yeah,
Okay.
there's no, yeah, if you, well, the decoder, yes, but I think the encoder would enforce a coupled stream.
I mean, it's a sensible thing to do, but you have to decide whether you allow it or not in the specification
I think
itself.
in the specification, I don't think it, I think we allow it. I don't think it necessarily breaks anything.
Okay.
So.
And so for mapping family 3, then I thought the idea was to make it possible to support partial order ambisonics. Is that still the case?
Yes.
So how do you
the way,
tell non-diegetic there?
yes, with the non-diegetic. The non-diegetic would just be an identity line at the end of the matrix, and if you wanted a mixed order and like a partial order, you would just have a 0 row for that particular input.
No, what I mean is, in mapping family 3, do you still force to have the full order be signaled? I thought the idea was that you were able to say, I'm coding 8 channels.
Oh, I see. Yeah, yes.
Because then you cannot use the square plus 2 rule to figure out whether that non-diegetic is present at all.
Right. So if you're, I think the way that that the doc reads right now, and I think our understanding of how we expect the input to be, is that you would always signal some n+1² with or without that +2 number of channels for either channel mapping. And if you were using partial order, you would need to submit 0 padded channels.
Okay. So, because I think the first version said you could specify any number of channels for mapping.
Yeah, and
so you're going to change that to...
I think we need to make that quite clear to explicitly allow, yeah, so we say that we explicitly allow that number of channels, and so we don't, so the only way we support mixed order is by sending zeros with as one of those number of channels.
Okay, thanks.
Sure.
Use our blue sheet.
Oh, yeah.
Since we had
No, I didn't pass them around because they were under my laptop.
Okay. If there's nothing else, I'll just sit down.
Any other comments from Jabber? All right.
Okay, thank you.
Thank you for coming, everyone.
How many people do you think are paying attention to this draft?
Approximately equal to the number of people in the room and on the.
How many people are paying attention to the Opus bug fixes?
I'd say roughly a similar number.
Well, if everyone in the room is actually paying attention, that's probably as good as a lot of working groups on some things.
You reviewed the update draft.
Well, the update draft are
Yeah. I think there are a few people who've actually looked at the Ambisonics draft who we haven't then been able to get to express an opinion on the list, but I know I've received a number of off-list comments about it. along the lines of we think this is great. What's happening? I did, and he's instead sent mail to the authors, which is also good, but
The good news is we have no tourists. Everyone that's doing stuff is actually very actively following and engaged.
Okay, that's an interesting way to spend it, a tourist-free working group.
Well, if we're not quick, probably. Yes.
yes.
And, yes, sure. I think, probably don't need to stir either.
All right. If there's no other business, thank you everyone for coming. Yeah, I think once you do that, it should be basically ready for working group last call. Once they address all the issues that people have brought up with the current version.
Remind me, from my ignorance, are the channel mappings part of the negotiated parameters that Opus provides?
So if you mean SDP, no. So
There's no on-channel.
yeah, SDP is mono stereo.
Well, mono, that's very.
Yeah.
So there's no way to know whether or not these ambisonics are supported?
Well, no, they are.
Yeah.
There is no RGB payload format for more than 2 channels.
So we had
Only container.
this comes up occasionally, and we say, well, if somebody is interested in actually doing multi-channel Opus over RGB, we should just make a new payload format for it. Just a separate payload identifier, and then no one's ever willing to actually do that work. So.
I guess once somebody has a business case for it, and fielding over what would be interesting, but not actually measuring and go to it.
Right. Which I mean, like, is good, right? Like not make standards something we need. Yeah. But we're happy to work with someone if they actually need it.
It probably wouldn't be too bad. You could probably just take all of the out stuff and say, this is how we translate an all mapping into
some SDP.
Yeah, but I feel like maybe very few people are using SDK for the kinds of things we use multi-channel. Typically, we use data formats for that.
Right.
Well, the odd containers were intended to be streamed, right?
Well, yes, over reliable transport.
not over unreliable, which brought all kinds of issues.
Well, UDP is reliable now. We're missing the quick session, right? So UDP is now reliable, apparently, if you go downstairs and. Oh, it's here? Okay. Next door.
I'm sure that probably people have served, Opus and over quick because YouTube use Opus now. Okay, so certainly, so I guess YouTube probably doesn't do more than stereo.
No,
That's around.
I'm not sure they have for Opus. They have around the.
So, but Opus is definitely been streamed over quick.
Yeah, absolutely. Yeah, I mean,
No, the chairs don't. Well, the chairs just have their name on the top, but on the side of the booth as such.
Do ADs automatically?
No, the name is